Hello and welcome to today's class. Let's look at the study of calculus under the limit of a function. By the way, when it comes to limit of a function, the limit of a function at any point describe the behavior of the function at that point. So when it comes to the study of limit, is a course under calculus, right? So it actually deals with the behavior of a function at a particular point with respect to another point. So let's say I have the limit of a function of x being equal to L such that s tends to a. How do you write that in limit concept? So I'm saying that let's say I have a limit of a function of x, that is f of x, to be equal to L as s tends to a, or perhaps you call it approaches a. This arrow here signifies tends to or approaches to. So this becomes your mathematical expression for limit. So when it comes to limit, there are several methods in solving problems involving limit. So let's look at several methods involved. Let's look at several methods involved in evaluating problems when it comes to limit. The first one is called the substitution method. Number two there is called the H method. We have the H method. Number three is called La Hospital rule. Number four there is called the series expansion method. Number five there is called limit at infinity. All right, these are like the several methods involved in evaluating problems when it comes to limit of a function, right? Substitution method, H method, the hospital rules. We have the series expansion method and limit at infinity. Let's look at this method one after the other. Those are the first one there. Number one, let's look at the substitution method. So usually when it comes to this method, your task is quite easy, right? It's as easy as putting the value of the given variable into the function. That's all, right? So take a few examples and look at how we possibly evaluate problems using the first method called the substitution method. So let's say example one. Let's say I have a function f of x to be equal to 3x squared minus 4x plus 2, and I'm given the limit as x tends to or perhaps approaches 2. So how do you possibly solve this problem? It's as easy as anywhere you see x in this function, just put 2. That's the concept. It's easy as that. So what's the first task here? To solve this man, we said using what the first method called the direct substitution method. We said just put your value of x as 2 into the given function. That's all. So for me now, the function of x, which is equal to what? 3x squared minus 4x plus 2. We said anywhere you see x here, put 2. So what will be the function when x is 2? This is now equal to 3 into anywhere you see x, put 2. That becomes 2 squared minus 4 into 2 plus 2. From here, if I do my normal math, I shall have 3 into 4. 2 squared is of course 4. Next up, minus 4 times 2 is 8 plus 2. This will give 12 minus 8 plus 2. So 12 minus 8 is of course 4, right? So 4 plus 2, that's 6. So this is equal to what? 6. So hence, therefore, if I have a function of x to be equal to 3x squared minus 4x plus 2, as x tends to 2, this is equal to 6. This is how to evaluate problems using the first method called the substitution method, as easy as just putting the value of x into the given variable. Usually, when it comes to limit concept, there are several topics you need to be familiar with, such as your SORD, right? Your rationalization. You need to know that very well, and your factorization concept, difference of two squares. Those are like the stuff we usually use when it comes to this man, right? So back to your year one concepts, you need this stuff, all those your year one stuff. So let's look at example 2 under this, and let's see how it works. So example 2, let's say I have the limit of a function, let's say x squared minus 1 all over x minus 1, all right, as x tends to 1. So how do you solve this? You said it's as easy as putting your value of x into the function, right? So x is 1. Anyway, see x here, just put 1. That's all. So solution to this question here, we said put x as 1. So I will have the limit of this function, perhaps x tends to 1. This becomes what? The x squared minus 1 all over what? X minus 1. You said put x as 1. This equal to 1 squared minus 1 all over what there? 1 minus 1. In this form here, we know that 1 square is 1, right? Even 1 cube is 1. 1 to power 1 million is still 1. So 1 square here is what? Is of course 1 minus 1 all over what there? 1 minus 1. This will give is 0 over 0. By the way, it's not proper in math for your denominator to be 0, right? It's not proper in math for your denominator to be 0. Hence, whenever your denominator is 0, it becomes an indeterminate function, or we call it infinity. So this is called an indeterminate function, or you call it what? Infinity. So note that in math, it's not proper for your denominator to be 0. Let's say for instance I have 4 over 0. If you point this one calculator, it will give you a math error, right? This is not proper in math. But if I have 0 over 4, this will give you exactly 0. So mind you, it's different from each other. So just note that whenever the denominator is 0, it becomes what? An undefined term, right? So which will give you 0 usually. So in this case here, here's the concept in limit. If I put a direct substitution, if I put my value of x as 1 here, I have 0 over 0. I'll now have to improvise, because in limit usually we try to avoid getting zeros. So here's the condition. I have 0 over 0 here. This is not a proper calculation, so I have to what? Improvise. So me using a direct substitution, it failed me. But hence now I'll now improvise using other concepts like factorization, difference of two squares, and etc. So here's the thing now. From here now, I'll repeat. Since I'm having 0 by 0, an undefined term, I'll now pick out the question again and solve using alternate method, right? So in this case here, we said we have the limit as s approaches 1. So this arrow is said to be approaches or tends to, right? Tends to 1. So I have x squared minus 1 all over what there? X minus 1. Observe your numerator. I'm seeing something. What am I saying? Look at the numerator here. If you go back to your normal concept from XS1, where I have a squared minus b squared. This is called difference of two squares. How do I express this? This is called what there? A plus b into a minus b. That's all. If I have, observe, this is a square and a square. Difference means minus. So difference of two square becomes what? That first thing plus that second thing, and also that first thing minus that second thing. That's all. So I will correspond my numerator in terms of this. From this one, I'm seeing x squared minus 1, right? Perhaps I can still write this as being x squared minus 1 square. 1 square is still 1, the same language. So break this down in terms of difference of 2 square. I should have what there? X plus 1, x minus 1. So here's the condition. I'll now put this expression into my numerator and repeat down the denominator. What should I get? So from here, I'll have the limit as x tends to 1. We said put this value as being what? X plus 1, x minus 1, all over what there? X minus 1. What you observe, applying normal math concepts, this man here will cancel this. What am I having left? I'm having x plus 1 left. But mind you, don't forget that we said put x as what? As 1. So if I put 1 here, so put x as what? As 1. What I have here, so that becomes 1 plus 1. What I have there? 2. So observe that when I improvise, I have 2. When I use substitution method, direct substitution, I have 0 by 0, which is undefined. So that's the condition. When it comes to limit, when you have 0 by 0, you have to take that question again and what? Improvise. So what I did actually, I just apply difference of 2 square and I had my answer as 2. This is how to evaluate problems using the first method called the substitution method. Let's look at yet another example under this and let's see what we get. Welcome back. Let's say I'm asked to evaluate these problems under limit of a function. How do you possibly solve this problem here? My very first task is to just open my eyes and look at this question. If you observe numerator, this numerator can be expressed as difference of 2 squared, right? If I have 4 minus x squared, I can break this down as what? 2 squared minus x squared, of course, becomes a difference of 2 squared. So I should have what there? X 2 plus x into what there? 2 minus x. But mind you, if I put this value, this one expression, if I put it here, observe that nothing will cancel out here, right? Unlike the previous example just earlier now, when we use difference of 2 square, observe that something cancels out. But if I'm to put this expression here, nothing can cancel out here. So in that case now, I will not use difference of 2 square here. Now here's the thing. In math generally, if I'm seeing denominator to be a square root, it's not proper in math for denominator to be a square root. Hence, how do you resolve such problem? You what? Rationalize, right? So let's say I have let me just show you the concept of rationalizing. Let's say I have root a minus root b all over what there? Root c minus root d. It's not proper for denominator to be a square root. To evaluate or to cancel out the square root, what do you do there? You rationalize. By what? By multiplying numerator and denominator by the conjugate of denominator. For instance, my denominator here was what? Root c minus root d, right? What's the conjugate of this? It's as easy as what? Change the sign. This becomes what there? Sorry, here is d. It becomes root c plus what? Root d. Conjugate, just change the sign. Now having root c minus root d, the conjugate becomes what there? Root c plus root d. So I'll multiply numerator and denominator by the conjugate of denominator, as easy as that. So for instance now, look up for this my question here. My denominator here is of course what there? 3 minus root x squared plus 5. What's the conjugate of this? This becomes what there? 3 plus root x squared plus 5. This becomes what? My conjugate. I didn't change the sign in the root, just the outside sign here. So this becomes what? My conjugate. So I'll multiply numerator and denominator by this conjugate. What do I get? In this case here, by the way, we are meant to use a direct substitution, right? If I to put x as 2 here, I'll have 0. You can try that to save time. That's why I didn't go through the process, right? So if you have to put 2 here, right? Observe, I put 2 here, now this becomes 2 squared, that's 4. 4 minus 4 is 0. But to put 2 here, I'll have 0, right? This one will give me, if I put 2 here, this becomes 2 squared plus 4. That will give 9. Root 9 is 3. 3 minus 3 is what? 0. So I'll have 0 by 0, undefined. So usually I'll not use that substitution method. So I'll have to improvise using rationalization. So at this point here, rationalizing, what do I get? We said I'll keep my stuff pending. The limit of x tends to 2, which is what? 4 minus x squared all over what there? 3 minus root x squared plus 5. Multiply numerator and denominator by what? The conjugate. That becomes what there? 3 plus root x squared plus 5 all over what there? 3 plus root x squared plus 5. At this point, combine the two. What do we get? This becomes 4 minus x squared into 3 plus root x squared plus 5. I have this all over denominator 3 minus root x squared. Hold on. Okay. X squared plus 5. Next up, I have what there? 3 plus root x squared plus 5. So I have this. All right. At this point now, what's the next task? I'll keep my numerator pending. I'll expand denominator, not the tax. So I'll keep this one pending. Expand denominator. What should I get? On expand denominator, for my numerator, I'll have this as being equal to what? 4 minus x squared, right, into 3 plus, this becomes root x squared plus 5, right? So all over, this becomes your concept under binomial theorem, right? So I will actually expand this using binomial theorem. If you don't know how to solve problem using Pascal's triangle or perhaps binomial theorem, I'll drop the link in the description of this video. So check the link. I'll drop a video that will teach you or that will explain the concept on how to expand term in this function. In this case here, here's the task. I'll pick out the first term in the first bracket, multiply by everything in the other bracket. Pick out the second term in the first bracket, multiply by everything in the other bracket. As simple as that. So pick out the first term, that becomes 3, into everything here becomes 3 plus root x squared plus 5. I'm done. Pick out the first term, everything. Second term is what? A negative what? Root x squared plus 5 into everything here. 3 plus root x squared plus 5. This has to expand to brackets. From here, what do we get from here? Repeat numerator. It becomes 4 minus x squared into what there? 3 plus root x squared plus 5 all over. Apply your math concept. 3 times 3 is of course 9. A plus sign plus. Now here's the thing. 3 times root x squared plus 5. That gives what there? 3 root x squared plus 5. That's the concept. Minus. Observe. 3 times root x squared plus 5. That's same what? 3 root x squared plus 5. I have this. Finally, observe plus minus plus is what? Minus, right? Minus plus is minus. Now root x squared plus 5 times root x squared plus 5. Here's the concept. Go back to SOD. If I have root a times root a, this will give root a times a squared. What do you know? Square cancel as what? Square root. I'll have a as my answer. Here's the layman language. If I have root something, multiplying root that same thing, matter becomes that thing. That's all. So if I'm having root x squared plus 5, multiplying that same root x squared, all I have as my answer, have a constant there, just what? X squared plus 5. Mind you, I encased it in a bracket. It must be in a bracket. Let's just say I'm having only x squared. I just write x squared, but I'm having x squared plus 5 becomes a family. So encase it in what? In a bracket this way. From here, what do I get from here? If I proceed, I shall have my numerator pending. That becomes 4 minus x squared into what there? 3 plus root x squared plus 5, right? So all over, what do we know from normal math? If I have a minus a, this is what? Of course 0 now. This cancel this. Plus 1 minus 1 is 0. Similarly, a minus a is 0. Perhaps plus a minus a is 0. What do we know? This one here, we cancel this one, right? So all I have there, I'll have 9 left, and what there? Minus what? X squared plus 5. Please observe what I did here, right? We said plus a minus a is 0. Similarly, plus this minus this is of course 0 to cancel each other. So I have this one left and this one left. So I'll try to simplify the denominator and listen up. Here's the task. I expect that something should cancel out. That's why I rationalized. So let's just see. From here, I'll have 4 minus x squared into 3 plus root x squared plus 5 all over. Here's the thing. This becomes 9. Minus times x squared becomes minus x squared. Minus plus is minus. I have what there? 5 here. Right? Evaluating this, I shall have 4 minus x squared into 3 plus root x squared plus 5 all over. Here's the thing. 9 minus 5 is what? That's 4. Right? Next up, I'm able to what? Minus x squared. What do we observe? This cannot cancel out this. So I'll have what left? This left. So here becomes this will cancel this. I'm having 3 plus root x squared plus 5 left. But mind you, we said x should be what from the question? Put x as what? As 2, right? So put from here, put x as what? As 2. What do we get? So this should give about this becomes 3 plus root, what's x there? That's 2. 2 squared plus 5. Right? This is now equal to 3 plus root 2 squared is 4 plus 5. I have this. Combine these two. This becomes 3 plus what? Root 9. Of course, root 9 is what? 3. So I have 3 plus 3. This will give what there? 6. So the answer to this question becomes 6. So observe that if I use direct substitution, I'll have 0 as 0. That's undefined, right? So in that other case now, I'll now improvise using this concept. So I have 6 as my answer. So let's have to evaluate problems using the concept of substitution method. Let's look at the next method in the next class called the H method.